Okay, is everybody back now?
Yeah. Have you tried grid
Yep,
view?
we're all in here.
Never mind. So
Yes,
anyhow, so I'm
Stephanie, we're all here. Sorry.
okay,
Yeah,
everybody's
there's
back.
50 people in here, so.
There are 50 people. That's wonderful. Welcome, everybody. I hope you had a chance to meet some of the people who were there and then talk a little bit about what your dirt means to you or your connection to soil. I have had my hand slapped for calling it dirt instead of soil, but some people make differences on them, but I don't know, it kind of takes me back to being a kid and just thinking about dirt and mud pies. So welcome everyone, and it is my distinct pleasure to welcome Kristin Ohlson. Kristin is going to be our presenter tonight. She's the author of The Soil Will Save Us: How Scientists, Farmers, and Foodies Are Healing the Soil to Save the Planet. Kristin describes herself as a writer with a wide variety of interests. Both her fiction and nonfiction writing have been praised for their clear storytelling style. And I know many of you probably have read her book and would agree with that. Her works have included anthologies of Best American Travel Writing and Best American Science Writing. And The Soil Will Save Us was a finalist for the 2015 Oregon Book Awards. I personally thoroughly enjoyed this book, and I'm very pleased to turn this over to Kristin. And my problem is going to be to turn it over. I have to get out of, I wanted to do this very smoothly and it's not going to. But anyhow, so welcome Kristin, and it looks like I'm not sharing my screen anymore, so you're ready to go.
Okay. Hi, everybody. Nice to talk to you. Let's see if I can share my screen. Okay. So I'm really pleased and honored to speak to all of you. It's a shame it can't be in person because it's so nice to talk to other people who are who love to grow things. So my book, The Soil Will Save Us, was published back in 2014, and there's really not a day that goes by when I'm not grateful to have been able to write about this material. Although at first it seemed to a lot of people to be a really boring thing to write about. You know, I had more than a few friends wondering if I had gone down a really weird wormhole, pun intended. But thankfully that's really changed. And I know for a fact that farmers and gardeners and scientists and doctors and urban planners and gardeners and scientists and other people all around the world are thinking about soil now, about how it's a living ecosystem and how the health of that ecosystem has enormous implications for our planet, for our water, for our air, for our food, for our health, for our climate. In fact, in the last couple of years, at least 14 states have passed or are working on legislation to promote and reward soil health. So all of this really gives me a lot of hope that we as humans can learn to live and work in harmony with nature and stop screwing up the planet. So I grew up in California at the edge of the Sacramento Valley, and from our house, we could look out across the valley at that vast agricultural expanse. My grandparents were farmers, and my father was involved with agriculture. He had an olive orchard with sheep wandering around between the trees. And rather delightfully, it turns out now that grazing animals in orchards is one of the best practices among a new generation of agrarians. The animals take care of the weeding and the fertilization and wind up creating great habitat for beneficial insects, and the farmers can eliminate or cut way back on pesticides and herbicides, as well as fertilizer. My father would be so pleased to find out that he was an example of enlightened agriculture. But as much as my father knew about agriculture and as much as my parents knew about gardening, they really didn't know anything about soil. And as interested as I always was in gardening and organic food, I didn't really know anything about soil until about 10 years ago when the great Cleveland chef Parker Bosley told me I should be writing about something called carbon farming. So he was one of those pioneering chefs who started bringing local food into his restaurant back in the 1980s. He had grown up on an Ohio farm, and he knew that the food that he served his customers was only as good as the ecosystem that produced it. So he told me that carbon farming, or also called regenerative agriculture or agroecology, or more simply the soil health movement, was the most important new trend in agriculture. So this is farming that actually builds the amount of carbon in the soil instead of depleting it as conventional industrial agriculture does. It's farming that makes land healthier, not sicker. It actually builds soil, whereas conventional farming loses 24 billion tons of soil every year. So what I developed in the course of writing this book and continuing to write about this stuff, and what I hope to share with you, was a profound sense of wonder at what was going on right under our feet. You know, I walk the earth differently, knowing about the vastness of life down there. Scientists think there are 300 sextillion stars in the sky. That's 3 followed by 23 zeros, a lot of stars. But down in the soil, there's a comparable density of microorganisms, an incredible 6 billion or so in a teaspoon of soil. So I'm guessing there are more than 300 sextillion microorganisms under Portland. These microorganisms have been found more than 10 miles down, but they're especially active around roots. We can't see these microorganisms, but they're busy making a living down below our feet, and everything we have and want above ground depends on what they do down there. I also want to give you what I think is reasonable new hope about our environment. Working on this book and learning about the promise of soil allowed me to take heart. I never doubted the global warming science for a minute, but it was hard not to be overcome by grief and terror, because it was obvious that we as a people we're not doing the things that will halt the buildup of CO2 and other greenhouse gases in the atmosphere in a timely way. I didn't realize it when I started working on the book, but the early climate science projections failed to take something huge into account, and that's soil. Most of us don't take soil into account. We mostly think of Earth, planet Earth, as this thin crust over a big dead rock that's hurtling through space. And even though I have a connection to soil that spans generations, I had no idea how alive it is. When I would hear or speak the phrase life in the soil, I mostly thought about earthworms and beetles and ants and other visible creatures, but they are the leviathans of the soil. They're the great blue whales and the giant squids and the great white sharks. It's the things that we can't see that make the soil so incredibly alive. The smallest life forms that have been there long before those other creatures evolved and are crucial to the way our planet functions as one great ecosystem, and we're crucial to this lush, beautiful world developing at all. The recognition of the soil microorganisms' importance is pretty new, and I think it's very much like the new recognition of the microbial communities in our own bodies. So our bodies have roughly as many bacterial cells as human cells. I think the latest count on the human microbiome, which is that busy community of microorganisms on us and in us, and mostly in our guts, is something like 100 trillion. So we're kind of like a ship of microbes, one that was pretty much designed and built by the microbes themselves. And actually the word that many scientists use to describe a human is a holobiont, Holobiont, an ecosystem comprising a host and many other species. And almost all the living things that we can see are holobionts, with a lot of the essential work being carried out by these invisible microbial partners. And it's not that we just have that one vast microbiome in our guts. We have smaller ones all over our bodies. And they're all different. So the microorganism, the stuff living around our teeth, is different from the one living in our hair follicles, but we probably need or have learned to coexist with them all. Scientists now think that those microbes are crucial to our body's functioning, to our digestion and our immune system and our metabolism, and even to the way our brains work, and compare their importance to that of an organ like a kidney or a pancreas. Incredibly complex. And of course, we humans are just a tiny example of the complexity of nature. When we look out at a landscape, we have to remember that there is a dazzling and necessary level of complexity everywhere. But our inclination as humans seems to be to simplify landscapes. What happens when we simplify our own inner landscape, when we take a lot of antibiotics, which kill off our internal partners, or eat Cheetos or Pop-Tarts for weeks on end? We get sick. So we humans have been carrying out a massive and deadly simplification of landscapes ever since agriculture began, and now much of that land is sick. And just as we're starting to understand now how we have to respect the complexity of our partnership with the microorganisms that live in us and on us, more and more people are understanding that we have to respect and support the complexity of our landscapes. The only way we can live on this planet without destroying it is to learn how to live in harmony with that complexity, to support it and support the relationships among living things that comprise nature. So soil is full of these relationships. Healthy soil has a vigorous population of constantly interacting microorganisms like fungi. You may know that a mushroom is just the fruit borne by the fungal organism underground, which sends its silky strands 250 feet and even farther through the soil, where they pierce the roots of plants and string them into a community. And there are also bacteria, protozoa, microarthropods, nematodes, and other tiny creatures in soil. Scientists have known that they were there for a while, but it's not until fairly recently that they understood why they were there and what role they play. And what keeps emerging from the work is this incredible partnership, an ancient, indispensable partnership between plants and these soil microorganisms. This partnership created the green growing world that modern humans evolved in around 276,000 years ago. The microorganisms have been in the soil for around 2 billion years. And when plants began moving from the water to the land about 500 million years ago, they tapped into an already existing system for cycling nutrients and water. So what are the terms of this partnership? We know about photosynthesis. This is the great biological marvel of our planet, which was begun by bacteria around 2.4 billion years ago, in what is often called the great oxygenation event, which changed our atmosphere into the one we have now. That was the first time living creatures caused climate change. Photosynthesis is now carried on by both plants and bacteria, and both create oxygen. But when plants conduct photosynthesis, they perform another function that's critical for keeping this world we inherited in balance. They use the energy from sunlight to pull carbon dioxide out of our atmosphere, and they convert that carbon dioxide into a carbon-based fuel, which they use to grow their stems and their trunks and their leaves and their flowers and their fruit. When we eat those plants, we are feasting on carbon that came from the atmosphere. It used to be floating around, and now it's in the sweet potatoes or the pomegranates or the flesh of the animals that eat plants. But plants don't use all of that carbon to fuel their own growth. Around 40%, and sometimes much more, is sent down to the roots, where plants strategically feed the fungi and other soil microorganisms this carbon fuel, which is really the elixir of life. In exchange, the soil microorganisms bring plants the minerals that they've liberated with enzymes from rock, sand, silt, and clay. And fungi bring more than just mineral nutrients too. They knit plant roots together and share water and chemical messages and chemical defenses within a plant community. For the book I'm working on now, I spent time with a researcher in British Columbia who studies forests, and she found that trees of different species shuttle carbon back and forth to each other through the growing season through this fungal network. She says that every time we take a step in the forest, there are 300 miles of tiny fungal strands underneath our feet. So this is a really foundational partnership in nature. There are other partnerships in nature that we know about because we can see them easily with the naked eye, like pollination. Animals like birds and bees fertilize some 80% of Earth's flowering plants in exchange for nectar and pollen. So we've been watching that with fascination for thousands of years. But up until recently, we didn't have the technology to observe the partnership between soil microorganisms and plants. It was tempting to look at a plant poking out of the soil and think, oh, here's this one living thing. But now we're starting to understand that when we see a plant, we're looking at the most visible part of a very complex ecosystem. And that if our vision could penetrate the soil, we'd be looking at a Boston or a Beijing or a Rio de Janeiro of microscopic life very busily at work around and inside that plant. There are 92 naturally occurring elements on our planet, and it's possible that plants need all of them or most of them to survive, not just a handful of nutrients that we give them in chemical fertilizers. And the way they've always gotten them is through that partnership with fungi and bacteria and their interactions with other tiny things living in the soil. So when we walk in the woods or in a meadow that humans haven't interfered with and see a mad profusion of plants growing there, we don't really ever think, wow, who dumped fertilizer there? But we probably don't realize that they are being fertilized by the microorganisms. So that's how the plant's partnership with soil microorganisms naturally fertilizes the plants. This partnership is also the main way carbon builds up in the soil. The microorganisms eat that carbon fuel that they receive from the plants, and they excrete it, and other microorganisms eat them and excrete it. And it's basically poop upon poop. It's all carbon. And then they die, and all that carbon from the plant's roots, which came originally from the atmosphere, keeps getting more and more concentrated and tucked away in the soil. And here's another way that carbon gets concentrated in the soil. It's not all poop and death. Fungi and other soil microorganisms make a kind of carbon glue to build tiny structures in the soil to protect themselves and control the flow of water and gases. They engineer the soil and wind up creating what I like to think of as cups and saucers, billions of them. Or another way to think about this good soil is that it's like a coral reef underground. That's what we're walking over, something that's that porous. So healthy soil is very porous. Because of that structure, it can receive and hold water in a way that unhealthy soil can't. And that's important because we all worry about rain. We either worry about how little of it we're getting, or we worry about what happens when there's too much of it all at once. This is the weather weirdness associated with climate change, either too much rain or too little rain. Healthy soil handles both of these concerns. For every 1% increase in soil organic matter, which builds up through that partnership between plants and microorganisms, an acre of soil can hold an extra 25,000 gallons of water. So if the rains don't come, the soil is still holding water from the last time it rained. And if 8 inches of rain fall all at once or in a few hours, the soil can absorb it and it doesn't all run off into the streams. The problem is that almost everything humans have done to the land since agriculture began has disrupted that ancient partnership between plants and soil microorganisms. It's not just a problem with modern industrial agriculture, although that is the most destructive way to simplify landscapes that we've ever come up with. Here are how the changes happened and continue to happen. Aeons ago, before the agriculture we now call conventional, we domesticated wild herds and changed the way they move over the land, and that began to damage soils. We dug up earth and plowed to plant our seeds, and that plowing destroys soil structure. Something like this photo became something like this over the centuries. We eliminate the great diversity of plants from the landscape to make way for the one crop we want to grow, and this is called a monoculture. And that lack of diversity above ground starves the microbial diversity below ground. We keep the soil bare around that one crop. By using chemical fertilizers, we disrupt the feeding relationship between plants and soil microorganisms, that partnership that I was talking about before, in which plants exchange their carbon sugars with soil microorganisms for minerals and other services. We keep using more and more fertilizer, and the environmental devastation is huge. Here's the dead zone in the Gulf of Mexico caused by furniture runoff. And we use killing chemicals, the herbicides, insecticides, and fungicides, and more, and thereby reduce the above ground biodiversity, which then affects the below ground biodiversity and threatens biodiversity in the surrounding landscape too. All these things disrupt the ancient partnership between plants and soil microorganisms and unhinge ecosystems. So when we started doing some of these things 12,000 years ago when agriculture began, we also started liberating carbon from the soil and sending it off to the sky. That was how humans first began altering the amount of carbon dioxide in the atmosphere, long before we were burning fossil fuels. Some scientists estimate 80 billion tons of carbon have been lost from the world's soils. Today, land use related to agriculture accounts for about 30% of the carbon and other greenhouse gases going into the atmosphere. All of that carbon that's in our atmosphere is called the legacy load. The climate change conversation that goes on in this country and around the world erroneously focuses on the 2 parts per million of carbon dioxide that human activity keeps adding to the atmosphere every year. We talk about that on, and of course it's super important, but the conversation doesn't pay nearly enough attention to the 410 parts per million that are already there, which is that legacy load. What if we managed to stop all emissions today? That legacy load would continue warming the planet. So we have to focus on removing it from the atmosphere. And the best way to remove carbon from the atmosphere, the cheapest and most widely available technology, the technology that's been at work for a very long time without glitches and without unintended consequences, the multi-purpose technology that also increases fertility and decreases water and air pollution and does so many other good things, is the technology that nature invented millions of years ago, photosynthesis, which removes carbon from the air, and that partnership among plants and soil microorganisms that fixes some of that carbon underground. So how much of that carbon can be fixed or sequestered in the soil? The research is ongoing, but my favorite scientist working on this is molecular microbiologist David Johnson from New Mexico State University. He and his wife, Hui-Chun Su, developed a new way of making compost that's rich in fungus. And he says that with very simple techniques, basically no-till agriculture coupled with cover crops, which are crops planted between the market crops or planted on fallow fields to improve the soil and to provide habitat for beneficial insects, plus an inoculation of good compost, we can create farming ecosystems that draw down and sequester as much as 11 tons of soil carbon per hectare. He says that if his approach were used on agricultural lands around the globe, the entire world's annual carbon output could be stored in just 22% of the globe's arable land. Our biggest impact on the landscape is through agriculture. There are 4.5 billion acres of pastures and rangelands. 4.5 billion acres of cropland and 14 billion acres of pastures and rangeland. Because of bad farming, the soil in most of our croplands and rangelands is sick, although thank God not as sick as this. According to Ohio State University's Ratan Lal, a quarter of the Earth's land mass is degraded and sick from human activity. But we can look at that really shocking number, a quarter of the Earth's land mass is degraded, and think of it as an opportunity. We know that using a combination of simple agricultural methods on the land and stopping the damaging ones, we can revegetate, heal soil, and draw down massive amounts of carbon dioxide from the atmosphere. That degraded land that's been stripped of its carbon is a prime target. So is anyone doing this? Yes, that's what the soil health movement, which is going on around the world, is all about. Not that all the soil health farmers are doing it because of global warming, but they're doing it to make their land more resilient, to grow better food, to stop erosion, to save water, to spend less money on chemicals and equipment, because healthy soil saves us in so many ways. The movement for soil health is all about mimicking nature in ways that enhance and protect that ancient partnership between plants, animals, and soil microorganisms. I talked to scientists when I first started working on my book about their research in this area, but many of them were quick to tell me that it was innovative farmers who were ahead of the curve. So this is the guy that I met, Gabe Brown, who has a 5,000 acre farm outside Bismarck, North Dakota. So he began 25 years ago. He began as a conventional farmer with tilling, chemical fertilizers, and other agricultural chemicals, as well as GMOs, and he still produces some commodity corn and wheat. He's not like the farmers at my local farmers market, who often got into this work because they have an idea about saving the world and doing something really good, doing something really positive. He wanted to get into this because he likes farming and he wanted to make a good living, and he does make a good living, which I think is really important. You know, people have to be able to make a good living doing this kind of work. He stopped tilling his fields because he noticed the soil was drier when he tilled. And then he had an epic 4 years of crop failure. You know, late frost, hail, a drought, and he couldn't take anything to market, and he couldn't afford any of the chemicals he had been buying. So he had his cattle harvest what was left of his crops, because that was the cheapest way to clean up his fields. And he started to plant cover crops in the fall to protect his soil. And in a few years, because of these practices, he found that his soil was changing, it was becoming darker and resilient and holding more moisture and healthier. So he started working with a conservationist and a scientist, trying to figure out if he could, on his own, manage his land and be a successful farmer without using chemicals and tillage. So he wanted to mimic the way nature grows plants. And he began to understand that his soil had become more resilient because he wasn't disrupting those microscopic soil communities through tilling. And he realized that his cover crops were keeping that underground community of microorganisms healthy by feeding them carbon fuel through their roots. So he increased the number of cover crops that he has. Again, trying to mimic nature, because the native prairie around him can have up to 140 different plant species in a square foot. And he realizes that cattle have I'm sorry, that's his book. He realized that cattle can have a healthy impact on the land if they're managed properly, because they're dropping their dung, which is loaded with microbes, and they're peeing, and that's full of nitrogen. So he increased his number of cattle, and he rotates them through his fields, taking care that they're there long enough to have that beneficial impact, but not so long that they eat the grasses and the other crops down to the soil line and stop photosynthesis. And he always talks about managing two herds on his property, the cattle and the herds of microorganisms underground. And of the two, he says the soil microorganisms are the most important. He always tries to manage the land for their needs. And now Gabe Brown uses no fertilizer, no pesticides, no fungicide, hardly any herbicide. To prepare a new field for his crops, he'll plant a cover crop cocktail, which is lots and lots of cover crops, and then clear it up with his cattle a couple of times. And the results, so the last time I talked to him, and it's probably better now, he was getting 27 more bushels of corn per acre than the county average. He was spending only $1.25 to produce that bushel versus $3.50 that the average farmer in the county did. The organic matter in the soil had gone from 1.7% to 5.3%, and his son is planning to take it up to 12%. And in a time when we worry so much about water, too much or too little, this is another really remarkable change, maybe the most remarkable change. In 20 years, they went from a half an inch of water infiltration to 15 inches in an hour. So his soil is so porous, so many of those cups and saucers, that it sucks up that first inch of rain in 9 seconds and the second inch of rain in 16 seconds. So altogether 2 inches in 25 seconds. So Gabe and his son, Paul, say they don't irrigate, and they say that they don't worry about drought, that their land is like a sponge that holds all the water that falls until it's needed, because it doesn't matter completely how much rain is there if the soil won't hold water. If the soil is compacted and isn't porous, rain will just run off and carry away dirt and agricultural chemicals into the rivers. So I think this is a really hopeful and exciting time. Gabe Brown is just one example of someone very consciously supporting the partnership between plants and soil microorganisms, and really trying to work with the many partnerships in nature. And he's thriving as a business person because of it. And there are thousands of other farmers on this path, on this regenerative ag path. And the message we can take away from their work is that we don't have to accept the false dichotomy that we can have either good food or enough food, good agriculture or productive agriculture, healthy landscapes or healthy profits. They're showing that we can have good food, good agriculture, healthy landscapes, and farmers who can make a living. So I recently talked with this organic farmer in South Carolina, whose name is Nat Bradford, and he grows watermelons, collard greens, and okra. And he's also doing really great soil health work. Unlike Gabe Brown, he did go into farming with a mission. He thought it was going to be something that would save the world. The funny thing is that he was discouraged from it by a high school ag teacher who said to him, no, don't go into farming unless you already have 2,000 acres of land and 2 million in farm equipment, you'll never make a living. So he went into landscape architecture instead. So his idea was to design healthy urban landscapes instead of ones like this one, which is right across the street from my house. Because he had heard that 25% of all chemical pesticides are used in city landscaping and people's backyards and in schools. So he set out to design landscapes that don't have big, bare, mulched areas that are most easily maintained by herbicides. Basically, what he was doing is what the regenerative farmers are doing, using cover crops. So he finally ignored his high school teacher's advice and got into agriculture, and he's been a tremendous success. He uses no chemicals on his farm and uses a lot of cover crops. And he's even figured out a combination of cover crops that grow, mature, set seed, and die down in time for him to plant his cash crop. So he doesn't have to clear a lot of bulky dead plants away. So you know how people often say that organic farming is fine for the elites who can pay a premium, but ignores the needs of ordinary people who can't afford the higher prices. By working with nature, Nat is harvesting 22,000 pounds of okra per acre, and that is almost 4 times the amount of the conventional farmers around him who are using chemicals. So with those results, he can beat them on flavor, quality, landscape health, and price. So let's put that argument to rest. We can figure out how to have healthy landscapes and productive agriculture. So we live in really challenging times. Of course, I don't need to tell you that, but I think that we have to remember that even the bleakest circumstances, there is the possibility of regeneration. So a young scientist I talked to in British Columbia is working on a project to reforest land ruined by a mine disaster, and she's planting new little trees out on that ruined land, each with a handful of forest soil. And that handful of soil contains what scientists call ecosystem memories, fungal spores, bacteria seeds, bits of DNA that can return the land to health. I love that idea of ecosystem memory, and I'm pretty sure that even in the bleakest places and the most degraded landscapes, those memories of life and the capacity for health and wholeness exist if we learn to treat the soil and all of nature as a partner and not as a spoiler. And in the long tradition of people who look to nature as metaphor, I firmly believe that if we can nurture and heal the land around us, we can also nurture and heal ourselves in the process. Thank you.
Unmute. Okay, so thank you, Kristin. That was great. And I'm sure that there are some questions. So does anyone have, okay, Mary, do you have a question? I see a hand. You need to unmute too.
Yeah.
Okay, this is the problem that me not being able to see. I can't see the hands, you guys. I'm sorry.
You want us to just shout out the question?
Yeah,
So Marilyn,
shout out the question. Go for
yeah.
it.
So Marilyn and then Linda Hartling.
Okay, I just about a week ago sat in a presentation with a meteorologist who was high on the technological ways to pull carbon out of the atmosphere. And I'm wondering, will healthy soil certainly addresses the carbon that's down at the ground level, and you know, but how effective is it for addressing those hundreds and hundreds of years of CO2 that are way, 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 way up there?
I think it's hugely important for addressing that. I mean, I talked about that earlier in the legacy load of carbon that's up there. I mean, it is plants that constantly and consistently take that out of the atmosphere and put it into their own bodies, and then as part of that process into the soil. So if you think about all the if you think about all the agricultural fields that you pass that are completely barren, and you think of all those other places on earth where humans, and it's almost always the work of humans. I mean, sometimes it's the work of a fire or a volcanic explosion or something like that, but where vegetation has been removed because of human activity, if all that were revegetated, we could have a profound impact on that legacy load of carbon. I mean, I think it's our best hope, and it's also our cheapest hope. I think that the problem is that so many people are used to thinking of, oh, we have to have a machine to do it. We have to have the technology to take care of it. We can't rely on nature to do this. We need a tool. And of course, there are many companies hoping to become rich on those tools. But I think that really we need to focus on our best tool, which is one that already exists.
And Linda, do you want to go next?
Yes, thank you very much. Kristin, I loved your book, loved it. And I'm so pleased to be here tonight just to see you. And I was just in a conversation with my colleague in Germany and about what they're trying to do and some of their discussion that was along the same line as your work. My question is, I'm in a global community and we see the impact of these big corporate entities on producing chemicals for agriculture and that long-term impact of disabling the land and the farmers in the world. And I'm just wondering, do you have any tips or good examples, or, what do you do about these huge entities that are making lots of money?
It's obviously a huge problem. The companies that exist and are convincing farmers that they need these chemicals, they stand to lose billions and billions of dollars if things go the other way. I think that somehow we have to push them back. I think that consumer interest has a lot of impact. I think it's happening a lot more that companies that aren't necessarily in agriculture but are taking agricultural products and turning them into other products. Those companies are starting to become very sensitive about their supply chain and very sensitive about stockholders and public sentiment about their supply chain. And so there is some valuable work going on that way to make the supply chains less, carbon squandering. But I think, that ultimately I think one of the biggest weapons that we have is going to have to be through government. I think that we're going to have government policies that demand a different kind of agriculture. It's our tax dollars that are supporting those vast conventional enterprises through the Farm Bill. So we have to demand a different kind of Farm Bill.
Okay, thank you.
So I'm gonna.
Ellen had her hand up for quite a while.
Yeah.
Okay.
And then you, Jim.
Okay.
All right.
Okay, my question is about lawns and what happens to your soil when you have lawns. There's nothing I'd like better than to have my neighbors all eliminate their yards, their lawns, and put in native plants. And I'm trying to look for additional compelling reasons why that would be a good thing and what that could do to the health of the soil and the ecosystem. So your thoughts on that?
Well, there has been some research about lawns showing they're not that terrible for the soil if they're managed right, and if they're managed in a way that doesn't look like the standard American lawn. So if a lawn is not mowed down so low, and if it has a diverse assortment of plants instead of just a monoculture, and if somebody isn't using chemicals to, chemical fertilizers and pesticides and all that in the lawn, and if they're not using gas engines to mow it, they're not actually that terrible. I mean, sure, it would be great if we all transitioned over to, personal landscapes that were using native plants and all that, but it's probably not going to happen. It probably can't happen completely. But I'm happy if people just manage their lawns in a different way, so they don't look like my father's lawn. My father dumped so many chemicals on his lawn, and he was just distraught if there was something that was other than that grass, that one kind of grass that was growing in there. But if we have a lawn, I mean, like my own lawn, I have a house that had way too much lawn, and so I've turned part of it into garden, and we're trying to turn other parts of it into a native plant landscape. But it's difficult to do. But I've probably got, I don't know, 30 or 40 species of things growing in my grass. It's all sorts of stuff comes up when you don't try to make it be a monoculture.
Yeah.
So Jim, newcomer, then I'm going to have Dave.
Yeah, I'm I think I tell a story about the original lawn was apparently King Louis XIV, and he had sheep grazing in the meadows around his palace, and everybody said, boy, that looks really nice. How do you keep it so short? He said, the sheep graze and da-da-da, and that was the lawn. And so anyway, I don't know if that story's true or not, but
I heard that too.
I have two questions. Here in Oregon, we see the battle going on around forestry, and the forestry department at Oregon State, for example, is wedded to clear cuts and destructive cash-oriented forestry rather than sequestration and healthy forests. I assume the same kind of struggle goes on in the agricultural departments, where they teach the fertilizer and they teach the pesticides and crop, cash crop, so forth. And I know this struggle goes way back. I taught at Iowa State University in the 70s, and I had students then who were sort of saying, I'm going to go back and inherit a farm. I want to start no-till. I'm not sure how to do it. And, striking out on this is 50 years ago almost. So what do you know about that's first question is, what do you know about what's going on in the agricultural departments of our land-grant colleges? I don't know where you are, whether you're in Oregon or.
I'm in Oregon. I'm in Portland.
Yeah. Okay. The second question then would be about the land bank or the carbon, there's like on the islands in the Columbia and some places forest reserves where people are beginning to take federal money and set it as use. Go ahead.
Well, I can only comment on your first question. I don't know what the second one is. Yeah, I mean, it's, we used to have much more public funding of ag departments in our public universities. And since the federal government began cutting back on that, private industry has flowed in with their money. So yes, I think that there is that struggle in all those departments. And in fact, some of the colleges that do best with a more ecological agriculture are not public universities, they're private universities, because they're not stuck with all that funding from the big chemical. But it is changing somewhat. I mean, and there are, I think there are more faculty and some more research getting into those departments. And Chico State University is certainly not one of the original land grant schools, but they have a whole department of regenerative agriculture.
They're right up there in the rice fields and the almond, as they call them, that almond orchards.
Yeah.
Yeah. A department of regenerative agriculture?
Mm-hmm.
Oh, that's brilliant.
Yeah, yeah.
So next, we have Dave Hawley. Dave, you just need to unmute yourself.
Going back to the first question about how can plants pull all the carbon out of the atmosphere that's way up in the air. If you look up Keeling curve, Keeling. Keeling was a scientist, but every year the plants from the northern hemisphere pull about 6 parts per million of carbon out of the atmosphere. And so that shows you the power of plants just on their own as they exist now.
Are you talking about that NASA image that showed it showed the heat over the globe changing as summer?
No, what I'm talking about is the curve that shows seasonal variation of carbon dioxide in the atmosphere. And if we look, it goes up from like 1960, we're at about 310 parts per million, and now we're up 100 parts per million higher at 410. But every year that curve goes up and down 6 parts per million. So what we see is in the summertime, the carbon dioxide goes down 3 parts per million as plants from the northern hemisphere draw carbon out of the atmosphere. And then as the winter comes on, the carbon in the atmosphere builds up again. So it shows just the seasonal variation of carbon basically caused by plants in the northern hemisphere drawing down carbon, then dying off. The next year drawing down carbon. Of course, we're adding in carbon every year. So that shows we can, we're currently at we're drawing down 6 ppm. The plants in the northern hemisphere are drawing down 6 parts per million of carbon every year, but we add just a little bit more. So we can draw carbon out of the atmosphere, the whole atmosphere. The atmosphere isn't static. Thunderstorms mix it up, and so that's this works. And then the other question is, have you followed the Rodale Institute's work?
Yes.
Yeah, because they're a
published my book.
nonprofit and doing incredible work.
Yeah, they published my book.
Okay, they were. Oh, they did. Okay, I'd forgotten that. Thank you. It's an awesome book.
Right.
That's all.
Okay. Should we go over to Mark and have him ask his question, or do you want to respond anymore, Kristin?
No.
Okay, Mark, you're on.
Thank you, and thank you, Kristin. I read your book shortly after it came out, and I tell you, I haven't picked it up since because I actually gave it to my father-in-law, who is a small farmer in Kansas, and actually haven't seen it since. But I tell you, it really stuck with me, and I really enjoyed it. And it was quite inspirational because, as one of the questioners mentioned, that about this other instance where folks that inherit farms, they want to do the right thing, they want to do the no-till and whatnot. And it was really inspirational for me because, yes, I'm, assumably we're going to inherit that farm and be able to carry some of these practices forwards. But the frustrating bit is a lot of these farms, like the idea of setting up maybe a demonstration farm where you can show that using these soil health practices, you can still produce a very healthy crop and a very productive crop. But yet you're surrounded by other traditional farmers that use Roundup and dicamba and all of these other chemicals that drift over into your farm, particularly dicamba, and it's really a bit frustrating to think about how you could be successful in situations like that. So what you said about going the legislative and the regulatory route is probably the best way to ensure success for these folks that want to do the right thing, but yet they're in the community where industrial agriculture, they're surrounded by industrial agriculture. So I think that's going to have to be the focus for this, is just to really try to change policy, not anti-farming policy, but in support of farmers,
Right.
to give these other, to give these traditional practices a chance in this mosaic of in commercial farming. I guess it really wasn't a question, but more of a comment. But there is one thing
about your family's experience.
Yeah, they're very traditional farmers right now, but you know, that's not going to last forever, because they're not going to last forever, I guess. Yeah. But there was, in your book, you mentioned an institute in Western Kansas that you worked closely with on this, like the Solvang Institute or something. I can't remember what it was, and I'll have to find the book again.
There was the Land Institute. I think I might have mentioned them.
Yeah. Maybe that was it. Okay.
Well, I'm gonna call on.
That's okay. That's okay, Kristin. Thank you very much again for talking.
And call on RJ, and then I've got 3 more people in line. So RJ, do you want to go really, Philip?
Yeah, I'll be really quick. Out in the Stafford Hamlet, we're surrounded by the 3 cities that are probably 3 of the most greenhouse gas emitters in our region and stuff. So what would be kind of your first steps you would take to kind of interface with them and try to come up with a carbon zone, and working with the rural urban interface, and maybe taking those first few steps?
I'm not sure what you're asking me.
Okay, we're basically a rural area surrounded by Lake Oswego, Tualatin, and West Lynn. That are the 3 larger greenhouse gas emitters in our area. So what types of first steps would you take to try to work with those cities and saying, like, hey, we can work with you and do a carbon sink out here of some sort?
I just don't know. I don't know that anybody's ever asked me that before.
I feel honored.
It's a good question, but I don't know.
Okay, and that's why we're trying to work with the sustainability group stuff and do some things like that. So
Yeah,
just
that's great.
thought I'd throw that out there.
That's great. A good idea.
Thank you.
I saw a while ago, Gabby, you had your hand up. Did you have a question?
Yes, but I see that Walt, I believe, had his first. How do you get that little hand up there?
I don't actually have one on my thing, so maybe.
Oh, okay. No, maybe I don't. An older computer. But Walt and Walt.
Yeah, I had Cindy too, and then Walt, and then Carol also has one. So I think it's just really, I mean, Stephanie, who do you think should go next? Sorry.
Well, I've seen Cindy's up for a long time, so.
Okay, yeah, let's go to Cindy. And Cindy, you need to unmute.
All right. Well, guess what? It's not Cindy, it's me. Cindy's husband. But my question is, what governments in the world at this point in time are supporting the kind of ideas that you have that we might be able to model in terms of convincing our governments to do these kinds of policies?
I'm not sure if anybody is doing it as much as they should, but the French have been, the French Minister of Agriculture has visited a lot of the regenerative farms here in the United States, and the French were the first ones to talk about they at the last climate conference, or not the last one, but at one of the more recent climate conferences, they put forward this idea of and I can't remember the name of it, but it's about storing it's about addressing the climate crisis by building up carbon in soil. So the French, I think, have been at least talking about this more than any other country.
Okay, next I'm going to have Walt.
Okay, first to answer the question of how do you get the hand up, different versions of Zoom have slightly different buttons around the borders, but mine has one labeled reactions. And when you click on that, you get a sub menu of lots of things that you can do, including raising the hand. So for those who don't know about that, you can try that. On my thought on the on what to do next, always seems to come down to education. And a friend of mine has the what I think is the ultimate way of educating young people. He has a pumpkin farm which hosts school kids. At least they did before the pandemic, and they will again. And the farm has a diversity of animals, and in addition to the pumpkins, he grows Christmas trees and vegetable starts and things like that. And he has been practicing no-till for a number of years now, and tries to be on the forefront of good agricultural practices, and then teaches that to the school kids that come to his farm. So I think if we educate our young people about the best ways to do it, they will carry it on, and we'll eventually get some change. It may not be as quick as we need to get the level of carbon down that we should. He also, by the way, drives a battery-powered car, and he would drive battery-powered tractors if they existed.
Thank you, Walt. That's a great example. And what we wanted to save our time here were direct questions for Kristin. And then I don't know if everybody remembered, we were going to have a chance to share those ideas about how we want to kind of move forward with this in the next section of the program. And we're going to run out of time. So does anybody have if your hand is up for a question now, is it a direct question for Kristin?
Yes.
And comments we want to gather too, but we have another way to gather comments and ideas.
So let's let Gabby go.
Okay. I was watching an interview with the new Secretary of Energy, and one of the things she mentioned was that she's going to emphasize technology for carbon sequestering. And I always had the impression that that was not a good thing, but would that be something that would be beneficial for this whole process, or does the process need to go through the plant? You know, the type of carbon dioxide, the CO2 need to go through the plant, you know, to be in the proper form for the soil?
Well, I'm not sure what she was talking about. I mean, there have been all sorts of ideas that have floated around of a technological removal of carbon from the atmosphere and then burying it somehow deep in the ground. And you know, I don't have any objection to somebody doing that, other than that it's exceptionally costly and might not work when we already have something that is not costly and does work. So that's my objection to that.
Okay, I have another quick question too. Does logging and deforestation, does that affect the process of the roots underneath those trees?
Yeah.
Their process?
Yeah, deforestation is like a big, when a forest is taken down like that, that's a great big burp of carbon dioxide that goes up into the atmosphere, and it's devastating for the biodiversity that's in the ground there. So it's, yeah, it's
And also, according to the Center for Environmental or Economics and Sustainability, logging in Oregon is the largest contributor of greenhouse gases in the state.
wow.
Carol, I think you will have the last question before we go to our next stage.
Okay, I have one comment for David Hawley, which is summer months may see less carbon dioxide, but I just heard that the rainforests down in South America have been eliminated to the point that they are no longer able to take out more carbon than they're producing. But my question is, are there any high school programs that are creating educational opportunities? I mean, now we have diversity and equality classes happening in our high schools. Why not a class about this subject? And are you aware of any?
I'm not aware of any. I think that probably, I hear every once in a while from teachers who want to get more of this material into their curriculum. So I think that, teachers are picking up, science teachers are picking up on some of this really new information about soil. But I don't know of a program.
So I want to thank everybody for really good questions, and thank you so much, Kristin, for sharing this with us. It was great.
Nice to talk to all of you.
Do want to go on, and I know people may have some ideas. So we were going to send people to breakout rooms to kind of capture some ideas or think about what we want to do as next steps in our community, to think about what are we going to do to actually support regenerative practices, both. And I love the fact that Kristin came up with the example of in urban and suburban areas, as well as agricultural. So
has everybody seen the movie Kiss the Ground? That would be it. Oh, you all should be watching that movie. It's on Netflix. It's called Kiss the Ground, and it's about regenerative agriculture.
Yeah.
Stephanie, I want to let everyone who lives in Lake Oswego know that there is a school board election coming up. And so this might be an opportune time to raise these kinds of issues.
So now, is everybody willing to go to, so let's go on to our next part of this. And for that, I'm just going to share my screen real quickly. But actually, is Laura here?
I'm going to leave.
Is Laura Masterson here?
Hi, Stephanie.
Hi, Laura.
Hi.
Do you want to say anything? Because we have somebody who's putting these together in our community, and Laura just wanted to give a real quick overview of some of the things that she's doing at Lesher Farm.
Sure. I first wanted to start by saying how inspiring Kristin's book was, and I think it was just so great for LOSN to bring her and have this event. So My name's Laura Masterson. My business is the 47th Avenue Farm, and I partner with the city of Lake Oswego to run the Lusher Farm CSA program. And I've been farming organically for 25 years and doing a lot of the practices that Kristin is talking about in her book and in her talk today. So, we use really diverse cover cropping systems to minimize bare soil and maximize food for the microbes. We do strip tillage and minimum tillage to try and reduce the impact to the soil or reduce damage to soil health. We actually have electric tractors. I have 2 electric tractors. I also farm with draft horses. All of the prep, that's what I could go on and on, but I think it's just really exciting to be here talking about this stuff. And if anyone wants to visit us out at Lusher Farm or wants to join us for our summer CSA season, to get, you can sign up for 6 months and get a box of food once a week from May through October. And that's through the Lake Oswego Parks and Rec program. So anyway, we're out there doing it, and I love what LOSN is doing, and I'm just so excited for the opportunity to share and be talking with lots of more folks about how exciting cover cropping and soil health is. So thank you.
Thank you, Laura. And I think it's exciting that we have such a good example right here at home and to think about. But one of the things that we wanted to be able to do is to actually kind of gather some ideas about what we can start to do to make a difference. And people through their questioning have started to gather some of those. But Mary was going to send us to breakout rooms. And then
7 minutes.
Okay.
Okay.
Quick ones.
Yes.
And then we actually will have people who is going to be kind of taking some of the notes in those rooms, and we're going to run out of time. So then I'm going to go ahead and take notes that everybody takes in the breakout rooms, and I'm going to share them out with everybody along with links to what is going on about soil, other things that we can do to learn about soil the rest of this month. So Mary, if you want to send us to breakout rooms.
Sure. I'm going to do it right now. Thank you all.
We're back.
Welcome back. I think we're almost all here. Do I have Stephanie here? Yes.
I muted when I came back in. So thank you, everybody who has stuck around to this point. And we will capture all those ideas that are coming up. And I just have one more thing. If people are interested in learning more, I really think there are things that we should be thinking about doing where we share our ideas a lot more. But we also have 2 other things coming up in Lake Oswego that I want to encourage people to participate in. And one of them is that we're doing a little workshop on get to know your work, get to know your dirt, which is actually delving in a little bit deeper than even Kristin did on being able to think about what's in our soil and how it's working and understanding that process a little bit more. But you'll actually be doing it. It's online, but you're going to be doing it with a sample of soil right in front of you. So you're going to get your hands dirty as you join in. And then the other thing we're asking people to do is become a part of the Soil Your Undies program. And with that one, you take a pair of tidy whities, and we have them for free that we're giving them away to people. You bury it in your yard for a couple of months, and then you dig it up and you see what it looks like. And it's kind of an amazing thing, because if your soil is good, the only thing that you will find left of your tidy whities is the waistband. So, and a little bit of the nylon around the legs. So the soil microbes will eat all of the cotton in it. So so it's a fun way to kind of start thinking about how healthy are the soils in our yards. And that could be in an apartment building or anywhere. Just find a little place and ask somebody, and bury a pair of undies. So you can get more information about all of those right on the homepage at oswegowatershed.org. And with that, I will be compiling ideas that have come back from people. The link to this will be on the LOSN website. And thank you so much for coming.
Thank you for having us.
Thanks for a great program.
Thank you.
Yeah.
Okay. Let's